On concept 16, we're using all the properties we know for complex numbers. On number 8, be careful first to determine what you're doing with these two expressions. We are subtracting these two expressions, not multiplying, but subtracting. If we're subtracting this quantity, we first need to use the distributive property. This is a -1, so if we distribute, we get -1 times -1 is +1. -1 times -3i is +3i. Once we do that, we can combine like terms. So the real part, -4 plus 1 is -3. -i plus 3i is +2i. On number 9, the operation is multiplication. So we're multiplying these two, -i, and simplifying -3i quantity squared. -3 squared is 9i squared. Anytime you see an I squared, we know that I squared equals -1. So I'm going to substitute a -1 in place of the I squared. -1 times negative is a positive, so positive 9i is the completely simplified answer. On number 10, we're multiplying this complex number times this complex number. So let's distribute, so +4, +12i, +1i, and +3i squared. Again, I squared equals -1, so make sure to simplify that. And also we can combine like terms. So we have 4 plus 13i. 3 times -1 is -3. So combining like terms gives us +1 plus 13i. Number 11 is a problem where we need to simplify this, and the goal is to not have a complex number in the denominator. It's okay to have a complex number in the numerator, but not the denominator. In order to do that, the process is always to multiply both the numerator and the denominator by the conjugate of the denominator. The conjugate simply means that we're changing the sign of the imaginary part. So 2 plus 4i, we're going to multiply by both the numerator and the denominator. So now we need to multiply across. So distributing here, we get 4 plus 8i plus 2i plus 4i squared. In the denominator, if we distribute, we get 4 plus 8i minus 8i minus 16i squared. Okay, continuing to simplify here, 4 plus 10i, if we combine like terms, 4 times I squared is -1, so this will become a -4. Here, the 8i's cancel, so we have 4. -16 times -1 is +16. And we then get, combining like terms on the numerator, 10i divided by 20. If we reduce that, that just becomes I over 2. Now, on number 12, we're graphing complex numbers and labeling each one. So point A is at -3. -3 is a real number. So on the real axis, I'm going to count to -3. We'll label that point A. It does not have an imaginary part. On part B, or point B, we have a real part of +3, so 1, 2, 3. Our imaginary axis is what we usually consider the y-axis, and we're counting -1 in that direction. So -1 in the imaginary direction, and that's point B. Point C, we're -1 in the real direction, +3 in the imaginary direction. And point D, -3 in the imaginary direction, which means the real part is 0. So I'm not going to go anywhere on the real axis, down 3 on the imaginary axis, point D. All right, number 13. we can start with the knowledge that we know I squared equals -1. So if we can break this up into a bunch of I squareds, then we can figure out what I to the 18th is equal to. So I to the 2nd goes into I to the 18th 9 times. So we could say I squared to the 9th. Well, we know I squared is -1. And then to the 9th, if you multiply -1 times itself 9 times, an odd number of times, you're going to end up with a -1.